Hello everyone, my name is Joe Burnett. I am a mathematics faculty member at the Eastern and Amarin campus, and I'd like to share with you some of the JEDI teaching principles that I have incorporated into my mathematics classroom. The first of which would be to incorporate assessment questions that build confidence during the assessment. As many of you might assume, that students in lower level math classes or entry-level math classes have a little bit of a confidence issue when it comes to solving certain algebraic type questions. So what I've learned is, or rather what I have incorporated, is to include the answer. So some examples would be asking students to compute the difference quotient. The difference quotient is a function application in a pre-calculus class that is very algebraically intense, and students either know it or they don't. Before I started changing the types of questions, I would say I'd have a handful of students that would be able to get the answer correct, and that's because they knew and understood the concepts. I'd have a handful of students that would have some confidence issues. They would work on the question for a set of time and then erase all of their answers and hand in basically a blank page because of all of their erasers. And then I'd have the majority of the students hand in a blank paper because they just didn't know how to do it, didn't know how to start it, or didn't know whether or not they were doing it correct and didn't put in the full effort because of their lack of confidence. So you'll see I would ask the students in this example to compute the difference quotient, and then I give them what the difference quotient formula is. And the new version of that same question is to show algebraically that the difference quotient of the function below is equal to 6x squared plus 6xh plus 2h squared minus 3. So I give them the function and I give them the answer, and this has dramatically improved their willingness to attempt and willingness to put themselves out there with these types of questions. I get a lot more feedback from students. I give a lot more partial credit, a lot more full credit, and just generally have much more participation on these questions from students. A similar example is, again, in a pre-calculus class, having students determine whether a function is even, odd, or neither. I used to ask them to just determine algebraically what the answer is. Many students would avoid the algebraic portion of this and just take a guess at whether it would be even, odd, or neither. And they wouldn't necessarily do it algebraically. However, what I've shown, or what I've done now, is ask students to show algebraically that the given function is neither even nor odd. And again, giving them the answer and giving them something to work towards allows them to have a little bit of confidence, and they're able to show the same algebraic work, which is really what I'm trying to get out of them at this point. But they have a little bit more confidence because they know what they're striving for. Another example is in Calculus 1, when I ask students to use the definition of the derivative. I used to ask them to use the definition of the derivative to just find an expression for g prime of x, which is part A of this question. Similar to the previous two questions, generally students either know it or they don't, and if they don't know it, they don't have any confidence in their answers, and they're not sure what to do, or that's at least what they tell me. What I've started doing with the Calculus 1 example is I tell them that the derivative is supposed to be g prime of x is equal to negative 8 over 3x minus 8 squared. So again, I give them the solution, and I ask them to use the definition of the derivative to show me this. For all three of these examples, I've seen the amount of work students submit has dramatically improved. I have seen students work much more diligently. They are erasing and working and just putting in so much more effort because they feel as though they have an endpoint. I have seen students on this particular difference quotient example work on this question 2, 3, 4, 5 times, erasing it, asking for scrap paper, trying it over and over and over again until they actually get the correct results, which is what the goal of this is to build some confidence and to build some algebraic abilities. Some additional JEDI principles that I've incorporated include growing the growth mindset within the classroom. I'm sure most of us have heard of the growth mindset ideas and principles. However, how do we actually incorporate those into the classroom is generally what I hear most. So I gave 3 examples of how I incorporate the growth mindset into classes. The first is to encourage students to try examples on their own during class, rather than just me doing multiple examples on the board and having them copy them down in their notes. I usually try and show an example, then give them a little bit more difficult of an example to work on their own. The difficulty with this is that it takes away class time, but it's an important aspect when teaching freshman and sophomore level students that they're able to do this. They can do this. It's going to be a struggle, but they're going to be able to persevere and succeed. The second way that I've incorporated growth mindset into my classes is to ask students to share their answers. Instead of asking students to share their answers, I ask them to share their questions. This focuses students on either questions that they have or questions that they think their peers might have. And it leads to a much more detailed conversation. It also shows students that it's okay to not know what to do, but it also builds on their ability to ask specific and exact questions that will lead them to the next answer, rather than, I don't get this, or I don't know what to do, or what's my first step. I try to get them to ask more deeper level questions as the semester progresses, and we generally end up having a much more detailed conversation. And the last thing that I try to do is not call on the very first person to raise their hand. Doing so emphasizes the speed at which an answer is achieved rather than the process through which the answer is achieved. And I want students to know that just because it takes them a few minutes to try and get the correct answer does not mean that they don't know how to do things. I try to incorporate the accuracy of results rather than the speed of results in the individual problem-solving process. Thank you very much, and I look forward to hearing any feedback.